Hello, in this video we're going to derive another integral, and here we're going to go from 0 to w of z raised to the k plus l plus 1 times w over z minus 1 raised to the k plus 1 over 2. And we're going to live in the z world, so it's dz. K and l are positive integers. W is a positive real number. Now, it's kind of messy at first here. So the integral, we're going to use integration by parts. And we're going to let u equal this piece here, which is here. So you take the derivative of it, and then dv is going to be this part. And then you take the antiderivative of it. Then what follows next is you take u times v, and that's what this is, and then v du, and that's what this is. Now notice it's usually a minus here, but this minus, when we take the derivative, changes that to a plus. Now here, when we stick in w for z, we get 1 minus 1, which is 0, which makes this 0. And if we plug in 0 here, it goes to 0. So this whole thing is 0. Now over here, it is what it is, you know, and we've reduced this piece by 1, and we've actually reduced this piece by 1. So let's use integration by parts again on this piece here. So it's up to there. So we let u be this part, and then we take the derivative of it, and we let dv be this part, and we take the antiderivative, and then now we plug it back in. We take u and v, and we get this piece here, and then we take v du, and we get this part. Now over here, it's going to be 0 again, basically. You plug in w, you get 1 minus 1, that's 0. And you plug in 0 to z, and it's 0. So this first piece will always be 0. And so then we get this second piece. Now, some notes here on the second piece is the first time we got w to the first power. The second integration by parts, we got w to the 2, and here there's one, you know, piece, and then we subtract 2 to get this piece. You know, there's a 2 raised to the 1, here's a 2 raised to the 2. This piece is what it is, and then we subtract 1 to get this part. So this is, it's kind of like a falling factorial, and this is like a factorial. I mean a double factorial, where you go down by 2 each time, and this is you go down by 1. All right, so now to skip a few steps, we're going to go dot, and we'll end up going to do this k plus 1 times. Okay, so here's the reason why. We have k plus l plus 1. So we want to do this integration by parts, k plus 1 times, to get rid of the so it's only z to the l. So notice when we did it, we got rid of 1. So we can do this until k plus 1 times, whatever that is. And actually then this ends up being, if you reduce this by 2 k plus 1 times, then you end up with what? This. So you end up with a minus 1/2 here and an L here. Okay? And so since we've done integration by parts, k plus 1 times, we get w to the k plus 1. We get 2 to the k plus 1. And there's actually k plus 1 terms here. It's a double factorial. And then this here is, you know, there's k plus 1 terms. So it's 0 to k. So that's k plus 1 terms. Well, let's rewrite this here. So in an earlier video, okay, so we leave the w the same. This piece here it's a factorial from k plus l plus 2. You know, if we go all the way down, but it only goes to k plus 1 terms, so we have to divide out when we get to l plus 1 factorial. But since it's a fraction, that means you multiply. So these two pieces ends up being this. And this together, if we were to take it times the square root of pi, this would actually be gamma, this gamma. But you can't just magically take it times the square root of pi. So you have to divide it by square root of pi 2, which is this. So this piece is this piece. So now let's further integrate this. Let's do a u substitution. Let's let u be this, well, sort of this piece, raised to the positive 1/2, not the negative 1/2. All right. And then when you back solve for z, you end up getting this. But when you take the derivative, you get this, okay? So what's nice about that is this minus w over z minus 1 dz, that's this piece here, right? So if we take multiply the 2 over and divide and take it up, then this piece here is part of, you know, it's this. So then you could just substitute in the other. And I wish I didn't have to flip the page, but I do. So when you make all the substitutions, you end up with this piece here. Okay. Now this we didn't change. It was only this. So now we raise that up and factor it in, and then we add the k plus 1, so that we get this. And there's a take it times a 2, and then you know, that comes out. We're in the u world, and then we just take that down. And my last video I put out says find the integral of you know, 1 plus x squared to the n, which is this integral here. So if you go to this video in my playlist called integration, you can find that this is 1/2 beta to the 1/2 l plus 2 minus 1/2. So we're going to plug this in. So nothing over here has changed. Now let's write this in its gamma formation. You know, the 2 and the 1/2 cancel, and we get this. Now we get some cancelizations. So this 1/2 cancels with this 1/2. L plus 1 factorial, that's what this is, so those cancel. And then we're left with these pieces. Well, in this factorial we changed to a gamma. Well, this is a beta. So you can replace it with beta. And then we're finished. So this is the answer. It's such a nice tight answer for our original integral. So that's it. So we just solved this integral. And the reason we're doing this is the second piece in a few videos that eventually I want to refer back to, you know, when I'm deriving something bigger. And so like we did here, we said, you know, refer to this integral, and it's this. And it just makes the video a little smoother, go a little faster. And this is just the second piece in something that I'm going to prove. And if you can guess it, what I'm doing in the comments, that would be pretty impressive. Anyway, hope you enjoyed it. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.